Single-phase induction motor is not self-starting, and it can be explained by using this double-field revolving theory. The instantaneous value of flux due to the stator current of single-phase induction motor is given by phi is equal to phi m sine omega t. Now consider two rotating magnetic fluxes, phi 1 and phi 2, each with magnitude phi m by 2 and rotating in opposite directions with an angular velocity of omega. Now, after a time t seconds, the angle through which the flux vectors have rotated is omega t. And resolving the vectors along x and y axis, we can see that the total x component is equal to, we are resolving phi 1 and phi 2 along the x axis. Then we will get phi m by 2 cos omega t plus phi m by 2 cos omega t, which is equal to phi m cos omega t. And resolving along y axis, we can see that the total y component is phi m by 2 sine omega t minus phi m by 2 sine omega t, which is equal to 0. So, the resultant flux phi can be written as square root of phi m cos omega t the whole square plus 0, which is equal to phi m cos omega t, which shows that an alternating field can be replaced or represented by two rotating fields of half its amplitude rotating in opposite directions. That is, an alternating field can be represented by two rotating fields of half its amplitude and rotating in opposite directions. Consider that the rotor is stationary. Then the stator is fed by a single phase supply, and alternating flux produced by it is represented as the sum of two rotating fluxes, phi 1 and phi 2, each with magnitudes phi m by 2 and rotating in opposite directions. Now let phi 1 rotate in anti-clockwise direction and phi 2 in the clockwise direction. Let T1 be the torque produced by phi 1 and T2 the torque produced by phi 2. At standstill, T1 and T2 will be in opposite directions and the resultant torque will be equal to 0. This is the reason why a single phase induction motor is not self-starting. Now let's assume that the rotor is started by providing some external force and it is rotated in the clockwise direction. Then the flux rotating in clockwise direction is the forward flux, and that rotating in the backward direction is backward flux. The slip with respect to forward flux is written as SF is equal to NS minus N by NS, which is equal to S itself. Now, the slip with respect to backward flux is written as Ns minus N divided by Ns, which is equal to Ns plus N by Ns. Now, for simplification purpose, we are rewriting it as 2Ns minus Ns plus N divided by Ns, which is again written as 2Ns by Ns minus Ns minus N by Ns, which is equal to 2 minus S. So, the slip related to forward flux is written by S, and that related to backward flux is given by 2 minus S. Now the power developed by a rotor can be written as Pg is equal to 1 minus S by S into I2 square R2. If N is the rotor speed in RPS, then the torque can be written as 1 by 2N into 1 minus S by S into I2 square R2. Now let's substitute N with Ns into 1 minus S. Then we will get Tg is equal to K into I2 square R2 by S. Now the forward and backward torques can be written as Tf is equal to K into I2 square R2 by S. And the backward torque can be written as minus K into I2 square R2 by 2 minus S. Now the total torque is given by the sum of forward torque and backward torque. Now what happens at standstill? At standstill, S is equal to 1 and 2 minus S is equal to 1. Then both these torques, Tf and Tb, will be equal and opposite, and hence the resultant torque will be equal to 0 at starting. So there is no starting torque, and hence the single phase induction motor is not self-starting. So double field revolving theory is a proof that the double field revolving theory shows that the single phase induction motor is not self-starting. Now if the motor is started in any direction, in any of the directions, suppose the forward direction, then slip S will be less than 1, 2 minus S will be greater than 1. So S is less than 1 and 2 minus S is greater than 1. So which will lead to Tf being greater than Tb. And if Tf is greater than Tb, then there is a resultant torque. And that resultant torque will make the motor run. The torque slip curve of a single phase induction motor is shown in figure, where we can see that Tf is the torque produced by the forward flux, Tb is the torque produced by the backward flux, and this is the resultant torque. And we can see that at slip 1, now the x-axis is slip, at slip equal to 1, that is at starting, the starting torque is 0. The value of torque at starting is 0. Hence, it's proved that the single phase induction motor is not self-starting. So it is proved using the double field revolving theory.